I have lots to get through, so I'm going to go kind of fast. I work at Christie. I do projection mapping. I turn things like that into things like that with multiple projectors for crazy things like simulators and theaters. That's actually a tiny theater. That's a giant theater, whatever. Buildings, other buildings. That's a gray car. That's also a gray car. It's the same car. There's the car. We're projecting color onto the car. Cars, whatever color you would like it to be. And that's how that works. So that's what I do. And I'm not going to talk about that. That's what I work on. That would be an interesting talk. Okay, Postmodern C++. I have a lot to get through. And I gave this talk before, but I needed to shorten it, remove some stuff, simplify it. And then I had an idea, an awful idea, a wonderful, awful idea. So let's see how it goes. Overview. We'll have some slides. I'll be your guide. On the slides, there will be tweets. Tweets and tweets on every beat. There will be graphs. Almost half the slides are graphs. That one is a strange laugh. Some of my talks are low, lock-free, atomic, which some might find quite abomic. Some talks are high, ideas grand, like this one, which we have here at hand. Actually, this talk is the yellow one, and it's not just high level, but it's about 3 feet in front of, in a different dimension than all my other talks. Bleed through all the speakers, it seems, another talk. Yes. Testing. Do I just talk louder? Yeah, talk louder. Man, did you miss my good poetry? All right. This still sucks. Hello, testing. Okay, I'm just going to talk louder. So I was summoned and am now on Twitter. However, nothing lock-free is glitter. We had a discussion. Modern C++. What is up? Where did it come from? Myers? Alexandrescu? No. Stroop. So, 1999. So modern C++ is old, and if you allow me to be so bold, postmodern C++ is where it's at. So let's see what's up with that. So shall we begin? Let's dive right in. The meaning of a container is the difference it has with the containers that it is not. At this point, I need to explain a guy named Derrida and what he was saying. He came up with this word, difference. Maybe you can tell from a glance, it's a mix of difference and deference. It's a word about words, a meta word, one that you may never have heard. I'll try to explain, I'll give it a shot. A sentence is words, some used and some not. Those not used may still add to the thought. A house could be a mansion, a hovel, a nest. Whichever word you choose is just more right than the rest. The others being wrong define that which is right. Its meaning, in fact, is found in that light. That's difference. Is that okay? If I may. Here's an example. I hope that it's ample. The Prime Minister of Ireland, Edna Kenny, resigned, and Jonathan questioned how UK's tweet was designed. Why not stable? Were they not able to give him that label? So the words not used can still add to the thought hidden beneath the words you see. All right, thank you. Jonathan's here. Another example. What is the meaning of foo? A function, a variable, an exception you threw? This is une instance of the ultimate différence. The meaning isn't here, it's deferred to elsewhere. If you can't tell, différence was a French mix of words. So foo is untext, defined only by context. So ladies and gents, does my tweet now make sense? Vector is not list. That is the gist. All right, maybe not quite that. Each container has its traits that define the places where they are great. Particularly vector, you don't need a lecture, just use vector. Never use list. So we can turn this into a guideline. When choosing a container, remember vector is best. Leave a comment to explain if you choose from the rest. Just wait. So this rule of adding a comment when you don't use an expected pattern is a sample of something that's subtle. If you're in the middle of a muddled puzzle that has you all fuzzled because a habitual pattern in a particular matter is not feasible, possible, or probable, you apply the habitual pattern, muddled puzzle defuzzler pattern, i.e. you leave a comment. So yes, that is also a pattern applied to pattern. So it's a meta pattern, a habitual pattern, muddled puzzler, defuzzler, meta pattern, which being a pattern can be applied to itself, making it a habitual pattern, muddled puzzler, defuzzler, auto meta pattern. Which means if you don't use an expected pattern and you don't leave a comment saying why you didn't use the expected pattern, then leave a comment explaining why you didn't leave a comment explaining why you didn't use the expected pattern. Truth is outside all fixed patterns. Okay. Deconstruction. Derrida, one of the founders of postmodernism, was also the creator of deconstructivism. Yes, that was a rhymism. Take some words, now turn them around. If one word was up, replace it with down. Does that lead to a smile or does that lead to a frown? What normally goes here, you place over there. You can do this without skill or not even a care. Now what do you have? Something moronic? Postmodernists like when it turns out iconic, ironic, and sometimes every once in a while it's even iconic. It was quite an interesting adventure when this was done to deconstructive architecture. Same principles. So, have a glance at the following instance, where I've taken an idea and turned it about. It's become a wonderful idea. You'll agree, I have no doubt. An API is defined by the code that calls it, not by the code that implements it. Yes? All right. First of all, JF, always with the mirth. On my tag there, Postmodern C, you need modern C first. APIs are defined by their classes and functions. Not so. Really, it's the code that is used at their junctions. Is that insightful, ironic, iconic, catatonic? So, another guideline. Write examples and tests first, I do say. Anything else will lead you astray. Once API usage has spread out ubiquitous, changing it then would cause a big ruckus. How it gets used is the API. That is something a class can't deny. I'm waiting for you to mention, Clang refactoring or something to solve this. Yes, of course, I would be a fool to not mention the Clang refactoring tool. But think of the code the way it was. But even then, surely there would be insights owed to all the former calling code, how you would fix the API. So this slide took me nearly a day, I bet. So I don't want to take it away just yet. It doesn't really fit with my talk, though. Pas de bleu sans jaune et sans orange. There's no blue without yellow or orange. That's another way of deconstructivism, that the words not used, the things not used are still tied together with the, if you think of blue, you should also be thinking orange. Or Van Gogh was insane, either one. There is no blue without yellow or orange. So, continuing, you must consider the bracket styles within the context of the socio-economic society in which they were formed. This is my attempt to compile something in the postmodern style. This is how postmodernists write things. But people make such a big racket of where to place a simple bracket. But why put developers in a straitjacket? Another tweet, how we write is as important as what we write. I don't mean to be contrite. Let's get courageous and talk about this thing that's religious. What is wrong with the first line? Tell me your thoughts and I'll explain mine. Anyone, just for fun? Clang format. The first answer is the line is in red. That would be using your head. But the first line is a pain at a particular time.
Debugger breakpoints.
Breakpoint, that's a great point. The lines aren't disjoint, so where goes the breakpoint? The problem there is the breakpoint goes where? Moving along, the second line might be wrong if you also code a lot of Python. I've never made that mistake, so for me the argument is hard to take, but whatever, some people find this style too clever. So on to these last two from my friend Fabio. This one is major versus minor, almost one-liners. The first one is for things that are inconspicuous, and the second one is for things that need special focus. So yes, in my code, I switched between styles. I let the circumstances decide which is worthwhile. And so honestly, a guy named Fabio showed me this, and I was like, don't do that. Like, pick a religion. And then he's like, no, you switch depending on context. So, fixed formatting is like trying to rhyme everything. Sometimes it just gets in the way of understanding. Yet I will continue. Allowing a variety of formatting can sometimes be quite liberating and helpful when communicating. Just don't take it too far. This code won an obfuscation Oscar. It was written by this guy, and obviously it calculates pi. The size of the diameter is the algorithm's parameter. Make the circle bigger, and you will get a more accurate pi figure. True. I was told to have graphs. More graphs. Turn your head just a tuck. See the duck? That's actually from an old, it's a 100-year-old joke. Bugs versus lines of code. Yeah. The line's not straight, yes. That'll be slide 98. So, for every line, there is a bug. For every bug, a hole is dug. Debuggers, profilers, and sanitizers you lug. More caffeine you have to chug. Add an if, that always works. Big picture understanding, shirked. But an if is a line, so an if is a bug. Sometimes all we can do is okay, removing all the aftermath so we can see the original graph. As was mentioned, unfortunately the graph is this is what the graph is like. This is what the graph is like. As you add more lines, the bugs will spike. So sadly, the line is not straight, but we'll come back to this, just wait. First, I have more graphs. A graph of width over height. Height versus distance from shoulder. This one's very accurate. This is also a graph of surrealism versus the progression of the talk. What's the chances Bryce is tweeting this now? Or is he tweeting that I'm mentioning him in the talk? Now he has to balk of which part of the talk to tweet. Warning, we're currently here. Yeah. Actually, even maybe at the ear, but not at the ossicones. Anyhow, back to a simpler tone. Yeah, graphs per slide. We're down at the beginning of that thing there. Why is this? Slides per slide is linear, unsurprisingly linear. Until we get to here. So obviously, that's not correct because the slide self-reflects. Okay, now I think you get there's another turn, but I think you get the pattern. So moving on. Okay, that was wrong. I think I can fix that. Give me a moment. I'll be right back. Okay, that should do it. Whoops, no. Okay, screw it. Time for the ultimate fix. All right. Let me just restart here. So where was I? I think it was this slide. Maybe this code explains what just occurred. Was this code connected to the projector? I work for a projector company. Not that one, but Christie's a projector company. So this class is self-referential. Maybe it has some potential. It folds in on itself, but does it do it quite enough? Let's add some CRTP to this stuff. Right? So instead of this, we have self, bliss. This is great. This is grand. Did I mention we have a band? Of course, it's never quite that easy. C++ rules can make you quite easy. This is what you would actually need to implement this. But this is grand? No, it is not. If you saw a code base using self, you'd be all, what? What? WTF, understand this code? Good luck. That rhymed. So we already have enough paradigms. This is from my manager at Adobe. I've since used this quote many times. Having too many paradigms is not sublime. I actually worry if metaclasses might fall into this crime. Too many of them. Okay, this graph is back. What we lack is a tact that gets this problem back on track. And unless someone like you cares a whole awful lot, nothing's going to get better. It's not. This is straight from Dr. Seuss, but that is not the original page. This is the page people on the internet have made. This is the original page. It's very much darker because our problem is a dark problem. So, how to concentrate on one section of a program at a time without intrusion, and how to test in isolation. Clickbait. Postmodern C++ began with the subroutine. In a moment, you will see what I mean. I found this amazing report, only 2 pages, very, very short. This paper is marvelous. There's things here for all of us. It's not by me, so it makes me jealous, but I'll let the author's words tell us. A self-contained part of a program. That is the subroutine slogan. An entity of its own. I know, your mind is blown. Here he says something courageous. Although you don't need subroutines, they're usually advantageous. Just write your whole program inside a main. And allow the coder to concentrate on one section of a program at a time. The rest of the program doesn't intrude. You can concentrate on each part in solitude. It's like you Would code, could code in a box. This kind of stuff will blow off your socks. And tested in isolation. This is a revelation. Such a fascination. It calls for a celebration. This technique deserves adulation and replication. Libraries. Let's take the code from here so it can be reused over there. That's so useful it's not even fair. You can do this all without pulling out your hair. Well, this was hard in 1951 when the paper was written. But today, no, it's still not fun. Using libraries still sucks. Making it all work takes a bit of luck. Now, modules. Those would be lovual. So, subroutines are bleeding edge, I say. But it will catch on, I allege. And I hope that you will pledge to use them when you're coding your next gaming cartridge. And here's why I consider it postmodern. I find functions are an unused pattern, and that is my concern. Enough of the sarcasm, but there is this big chasm between the promises of functions and how they are used by us bumpkins. Note that reuse is probably the least important. That, at least, is my argument. So let me tell you a fable that's able. A bitchin' depiction, somewhat fiction, but a suitable rendition, a manifestation that aids elucidation, and a fine addition to my collection. I searched our code base for step 1 to get a feel for how our code is done. Here's a simple sample that we can trample. Step 1, do some stuff. Step 2, 3, 4, and then that's enough. Do you really need to be ultra keen to put step 1 in a subroutine? And then give it a name, like step 4, right there's an unused name. Validate fit, what a shame. But the search also uncovered, well, some duplication was discovered. Yeah. How many times must the same code be seen before you make it a subroutine? 2? Anyone else?
3 good ones.
Once per platform? I like this question. In interviews, it's fun. The right answer is 1, right? You don't need to see the function you don't need to see a block of code more than once to give it a name, make it a function. You don't need to be duplicated at all in order to elevate it to a function call. Why is this so hard? Why is it subroutines that we disregard? Laziness? Craziness? There is no hocus pocus. I think the answer is focus. Too much narrow focus in the wrong dimension. We need to widen our focus in another direction. Do this when we code. You've got a problem close at hand. Your mind holds all the context, a complete map of the land. So if you make a function call, you're afraid this edifice will start to fall. What you've built will start to crumble. All those thoughts will jumble and tumble. You stumble and fumble, left there to mumble and grumble. But if I may, there's another way. With functions, you put each small problem away. Then there are less things in your brain that need to stay. You're left with functions that each do but one thing. And these are the advantages it brings. Right? Reuse is the least important to me. All right. We had a discussion about postmodern error handling. It turns out Andrew Pardoe's knowledge of postmodernism is dazzling. Put a link there to this guy named Francis Lyotard. He mentioned Lyotard, another postmodern founder, which is where my postmodern knowledge starts to flounder. But applying his work to C++ with a little bend, it's that the answer is always, it depends. You choose whichever solution you please based on each situation's particular priorities. That is our curse. There is no universal solution that brings a problem to resolution. There is in languages like Java. You just pick the design pattern that others have traveled. But we are a language where details matter. Choose what you want, smaller, faster, understandable, maintainable, the former, the latter. But here's the error handling I really wanted to talk about. Anyone seen a TED Talk? To the center of the stage I walk. I speak a bit more softly and list some things on my fingers, 1, 2, 3. So now the next thing I say will really sink in. If there are awards, this talk should win. And if I need to make it stay, I just repeat things I say. This talk should win. This talk should win. This talk should win. So, no awards? No? Well, nonetheless, that's a trope. A pattern or way that is conventionally used when you have something to say. And often the author knows that you know that is used in that way. So here are the error handling tropes. But the real question is to which audience you spoke. How you tell is related to whom you tell. If you have an internal library error, tell the author. Maybe logging or a crash dump that the user forwards. The calling developer is not the same as the calling code. That is something I feel must be told. If a developer makes a mistake, there's no code path for the error to take. Pass a null reference, that wasn't planned. So to handle that error, there's no code pre-canned. Instead, find a transform where the developer is informed. You tell the calling code when the error was foretold. Like file not found. That should be expected, and the code should be sound. By the way, exceptions are for exceptional cases. No, that argument is baseless. So, just to be clear, I'm just going to not rhyme for a second. If I write a library and it detects an internal error, it has to tell me, the library author, somehow. However you figure that out. If you call it wrong, then it has to tell you, not the code that called it, but you, the developer who wrote the code. How are you going to get that information to the developer that he made a mistake? But a normal error, you call the calling code, because that calling code will be able to handle a normal error. And then most of these things will trickle up to the user. So even if it's just termination, you're telling the user something very rudely. But my point is, knowing which person you're trying to talk to will change the way you communicate an error. And you might use different ones for every situation. That's my thoughts on error handling. The postmodern smart pointer. I promised in the abstract. So anyone want to guess what the postmodern smart pointer is?
Raw pointer.
Raw pointer. Close. So close. The postmodern smart pointer, observer pointer, is somewhat absurd. It follows the smart pointer trope in an ironic way, but with a value, I hope. The pointer's not mine is a hard thing to say, but this does it in a compilable way. So it manifests what was previously a comment at best. There you go, postmodern smart pointer. This to me is the epitome of postmodern tweets by me. Two readers reading the same source may see different values due to what each read and wrote previously. So if I'm an English major, source is some text, and how it is interpreted is based on the reader's context. Similarly, if the reader's a coder, their background can make the source misunderstooder. But if the reader is a CPU thread, then source is a piece of memory whose value is usually a mystery when coding anything lock-free. So this tweet is really multi-level. When I wrote it, I was being very careful. I'm flying through here. Sorry. Yeah, I know where I'm at. I'm at the conclusion. I'm halfway through. I'm at the conclusion. In sooth, I know not why I'll code so bad. It wearies me. You say it wearies you. That's the opening line of Coder of Venice. I'm sure you all know it. Venice is known for its beautiful glassware, so it's like its own Silicon Valley. Okay, Silicon Marsh, swamp, Silicon Swamp. But to really explain this properly, I need to go back to the beginning for a moment and do a postmodern critique of my talk. So let me just go back here for a second. And now you're wondering if I really exited anything. All right, there we are, back to the beginning. So a postmodern analysis of the postmodern C++, which is the postmodern look at programming by Tony Vineyard. So we have to ask, why did the author choose Twitter? Anyone? Self-contained pieces of information. I like that. Existing material, yes. I pre-planned my whole talk by publishing it on Twitter. Well, like coding, Twitter is a very constrained platform, right? And coding is very constrained. You have to work within the syntax and everything. Also, Twitter is very social, and it's all about communication. It turns out coding is also about communication between developers. So that's why I chose Twitter. Now, why Dr. Seuss? Well, it's also constrained. Also, the author may be insane. Me. If nothing else, it's an example of how strict formatting can be detrimental to understanding something. And honestly, that just rhymed, but I didn't mean it to. Just once you start rhyming things, it just happens. So Dr. Seuss is also a constraint, and it's also, but it's also about common experience, right? We all know Dr. Seuss, or we don't. I was talking to someone from Europe who had no idea what I was talking about. Doesn't know who Dr. Seuss is, but North America, we all think, I just assume we all know who Dr. Seuss is. We run into this problem in code. We assume that people have common experience as us. They have the same background. They should know, you leave a comment, they should know what you're talking about, that kind of thing. Note that I actually left a reference to Dr. Seuss in my opening remarks about having a wonderful, awful idea. And tropes, right? Why did I want to talk about tropes? Again, it's common experience. Tropes, which are just patterns in code, only work if you have a common experience. Graphs. Why graphs? Well, how can you have a talk without graphs? That's obvious. But I have graphs. All my graphs were basically devoid of content because it's like the word foo. My graphs were foo. It was there for formatting, that a talk has to have graphs. Therefore, I followed the formatting rules of a talk. So what I really was talking about in the graphs was formatting. And
comment on the meaninglessness of others' graphs.
This whole thing is a talk on meaninglessness, I'm sure. And déférence. What's up with that? That is, in some sense, syntax, right? You take a sentence and you look at the words and you replace words with other words, and it's trying to get at the meaning of a single word. And the point of déférence is you can't get the meaning of a single word without understanding the meaning of all other words. All other words. Like you start with one word and you think of the other words that could be replaced, and you think of the definitions that this word is based on, and it's based on other words, and it differs forever. And we have that problem in code a lot. It's just like one small piece of code, you have to understand so much else to understand a small line of code. And because it's all about context. Bruce Lee, what's up with that? It's a reference, right? Why? What's up with all these references? We'll get back to references. Deconstruction is another weird thing that not only is it about syntax, because you replace pieces of a sentence with words that can be substituted, which in coding, you change one thing and your code completely changes. If you're lucky, it's a compile error, but otherwise you just get, something you didn't expect just because you changed one letter sometimes. But deconstruction is there for a way to get a new perspective. You look at something and you try to look at it in different ways. It's a way of thinking. Van Gogh is also a different way of thinking about things, and it's also just another reference I threw in. And then I talked about formatting. But I'm linking formatting with communication, which you can argue with but we have these constraints that we have to have code that compiles, yet I'm trying to communicate with you. So why tie me down to how I'm going to communicate? Like, let me format whichever way I think will communicate best in the situation. And bugs. Finally, we get to the problem at hand, right? Or at least a manifestation of the problem at hand. What is the real source of the problem? Bugs are just the result of some underlying problem. And then, WTF. Why do I do things like that? I'm trying to stretch your mind out a little bit, right? Think of things a different way. See things differently. And be aware of yourself and aware of the big picture while you're coding. You should be aware of what the whole context is. And I just wanted to mess with your brain a little bit. That's the point. And then I brought up, I'd like to be sarcastic about this paper as if it's brand new technology. It's from 1951. But is it a solution to the problem? Because I really think we don't use enough functions. And maybe it's that simple. It's like Monty Python's, the answer to the meaning of life, Monty Python's thing was people are not wearing enough hats. So that's my conclusion. I review tons of code, and one of the main things I say is put that in a function. It's like, I don't care about classes, so many other things. It's just take this code, put it in a function. And, is it that simple? Just the world needs more functions. Okay, now wait a second. Now my postmodern analysis of my talk is also using references. So let me give you a postmodern comment on the postmodern analysis of my postmodern talk. This is a reference to Monty Python's Meaning of Life, as I mentioned. But where do these references end? Should we reference the Gabon paper here, the crappy Gabon paper? This is, of course, a reference to a comment about a reference in a published paper. Let me explain that. Yeah, my explanation is a reference to a comment in a published paper that the comment got mistakenly left. They were thinking, should I put a reference here? That's the exact quote. Should we reference the crappy Gabon paper? But because of our shared experiences, if anyone has seen this quote before, there's a good chance you saw it in this paper about burritos for the hungry mathematician, because he quotes it in here. And this is a paper, of course, on monads. Also, it seems to harken back to the 1999. Everything's connected. So how is it possible to understand that many references in a piece of code? Same problem. Stop using references and pointers. Use value types. So, real conclusions. I did go really fast. Okay, that was 200 slides. We have context. That's the big theme here, is what context are you working in? How do you maintain that sense of context when you're coding? And communication. You have to communicate with the compiler, first of all. But you're going through the compiler to actually communicate with the computer, right? That's what you're trying to tell the computer to do something for you. And that is for the sake of the end user, who's you're really trying to communicate to. But during all that, you also have to communicate to the programmer, right? How do you do all that at once, right? It's like, maybe practice. I don't know. Like it's, Shakespeare did all this stuff in iambic pentameter. That was my other choice. I was going to do this in an iambic pentameter. But he still communicated, the human condition. So communication is hard, but we should try to do it. And then we have all these constraints and format and syntax and ambiguity. And I put patterns on both sides of the. One side is kind of the problems. The other side is possible solutions. This is the summary of or the abstract of my talk, right? And the main thing is that when you're coding, we think so linearly on a problem at hand, right? You're just focused on this path of the code through the code base. It's like bug happened here, you went down here, add that if statement, fix the bug. And you're not thinking of the real coding graph is much more complicated. And we just put blinders on, and we need to think more like this. And the goal of this talk was not actually for you to watch me. The goal was for me to watch you, and for you to watch you. So my goal was, did you follow along? Were you picking up these strange ways of thinking? Are you starting to make rhymes in your head? So I have this theory that you can't teach good programming. It is a way of thinking. It's your personality is in your code. And I would like to be proven wrong. And this is my first attempt to prove myself wrong, is that you can teach people to code a different way. And the way to do that is to make them think differently. So there is no strike through in the formatting of our abstracts. My real goal is to change the way we think. Because if we can't change the way we think, we can't change the way we think about programming. So that's all. Like it's try to think in this, try not to be stuck in one mode thinking. We think so linearly, and we shouldn't be doing that. And that is, I've gone way too fast. And thanks to Dr. Seuss, today is done. Today is gone. Today was fun. Tomorrow is another one. And I want to apologize to the C++ video access team who are trying to translate all C++ talks. I don't know. I don't know how they're going to translate this talk. Any questions? Yes.
So in the slide with the various if statements and the color combinations provided, why did you skip the obvious red if, blue if?
One
joke?
fish, two fish.
Yes.
I'm never going to give this talk again, but I will write that down. Thank you. I failed.
What is the crappy Gavin paper?
The crappy Gavin, I don't know. The paper is something to do with whatever it said there, biology of invertebrate things in the ocean or something.
I may have a way for you to kill time. Do you have the Bruce Lee slide deck on your laptop?
Oh, I have bonus slides right here.
Of course you do.
I should have mentioned that. Yes, okay.
Okay, so you, Tony, rest all of your hopes on engineers employing tropes. But how can we, in your sharp mind, these tropes into our language enshrine? Modules, perchance, come to mind, but others maybe can you find?
Others maybe. What was the last bit of the question actually?
Do you want it in rhyme or not?
No, because obviously rhyming, no one understands what you're saying.
Just that you're talking about tropes and talking about conventions of programming and using conventions to make our programs more readable and more understandable. We have things going into the language to enshrine things like modules are kind of a in-language way of header guards, for example, that that encode good practice into the actual language semantics itself? Do you see anything else coming up that might like also take things which are now conventional and turn them into something which are actually part of the language?
Yeah, I think we try to do that all the time. I have two thoughts on that. Like variant is an example, right? We made a variant class, but it might be good to have variant built into the language, right?
How do you really feel?
Do I have... My phone is beeping at me to remind me of a talk. But the other part is paradigms and tropes are both good and bad, right? Because what you always end up doing is going to a code base where they're using all these paradigms that you're like, what are you guys doing? Like, why do you code like this? And they're like, we code like this because we've always coded like this. And it's just, you can trace it back to one guy who started coding that way. You know, and as someone else coming into a code base, you're like, these are all, and I've done this before where I tried to use different paradigms in our code base. And my manager, that's the case where a manager said, we have enough paradigms. It's like, the code I was writing wasn't wrong. It might actually have been better, but it just didn't fit with the current code base. And he's like, people are going to read this and not understand what you're doing. Just do it the way the rest of our code does it. Sometimes that's a good thing. Sometimes it's a bad thing. It's good so that people can understand things easier, but it also, you're making an assumption that people are going to understand. Because you're like, oh, everyone knows this pattern. No, they don't.
Thank you.
I have bonus slides. I forgot I had bonus slides. They were just here from last time. C++ cones. Master, it says must do X first, but why? Check Git. After a week of finding nothing in the archives, the student was enlightened. So, I mean, if you all understand cones, right? They're like short little stories where there's enlightenment at the end. And I had this crazy idea that I would write C++ cones, and I thought, wow, that's going to be really hard to do. And then I thought, no, I have to do it within 140 characters. So I thought, okay, that's insane. I won't be able to do it, but I've got like 5 or 6. Does anyone understand the enlightenment in this story?
The comment is wrong.
The comment is wrong. The comment wasn't wrong in this case. This is a true story, by the way. Comment was right, but there was something wrong about it. I'm not supposed to give, like, the other part of a cone is you're not supposed to explain them, yet I'm here. Because you really don't feel you don't get the enlightenment unless you spend the week looking through Git to understand the comment. Then you become enlightened. Because you spend a week in Git and you find nothing. Then you're like, ah. Anyone enlightened from that? Yes. Yeah, the code does A first, does X first, and then it does Y. And just like the comment says, must do X first. What's the problem with the code or the comment? It doesn't explain why. Thank you. There's the enlightenment. I actually did this. I had a piece of code that said, must do this first. And it was causing a bug. I had to switch the code around to do the other one first. And I'm like, but why? It says right here, do this first. I'm like, I can't change it, but it's causing a bug. I have to change it. So I went looking through Perforce, and back before you had git blame and all this other stuff, traced it back, and it took me tons of time, and I finally found who put that comment in. It was me. So now all my comments include the word otherwise. This is also a true story. Lock-free master, we need Q. Search the code base, then typed thread safe Q equals mutex Q. T. Anyone enlightened by that? You must be, this totally makes sense to you, right? Yes? Titus, do you have a comment that would excite us? I was prepared.
Lock-free types are a beautiful parlor trick. I'll leave it at that.
Lock-free types are a beautiful parlor trick, yes. This really happened. People came to me and said, Like we had a problem. It's like, oh, we could use lock-free Q here. And they just stared at me like, I'm going to write one now because I do lock-free programming. And I went, here's a mutex Q. It works. We're done, right? Go measure it if you think you need something better than that. The rule of zero. Explain the rule of zero. Study the pointers of masters Hinnett and Dimov. But they have destructors. They don't follow the rule of zero, as they should. I'll just keep going. Near sprint n, master found them arguing n versus log n. She typed the solution. It was n squared. One left in disgust, the other enlightened. Is that good? Everyone good with that? Yeah, she's just nodding. Take a gander at Chandler. No. Okay, I actually have some. I've written one since then, but it's not in my slides. It's somewhere in Twitter. You can find one more C++ cone hiding in Twitter somewhere. And I'm going to say I have no more bonus slides. Yes. That's it.